Welcome to Mr. V Teaching Math. In this session, we're continuing to look at simplifying algebraic expressions and equations. We talked a little bit earlier about doing BEDMAS. Now we're going to learn the first technique called Gathering Like Terms. I have some examples to do with you. A term. Each of these things is a term, a piece of an equation, if you would like. And they are like each other. And therefore, we are going to gather them. We're going to collect them together. Now, if you remember, the lazy mathematician, there's a 1 in front of each of these. It's helpful to think that way. In fact, if you really want to, you could write them in, if that helps you do your math. Because if you think about this, I have 1x plus 1x plus 1x plus 1x. Well, what does that equal? Well, that's 4 x's. I have gathered the terms that are like each other into one thing. Now, you'll notice this is the answer. Many students start getting confused at this point because when they say an answer, they expect to have a number, to be finished and to be all finalized and have a completed number. You will note that this is not a number. And that's going to happen in more and more questions. Another example. 2x plus 3x plus, once again, lazy mathematician. 2 plus 3 plus 1. I have 6 x's. Another example. Ooh, a little bit more challenging now. You're now subtracting. You've got to be careful with subtraction. Remember, the subtraction always belongs with the term that comes behind it, and that's important. We're going to run into that in a few minutes. So now I have 2 x's minus 1x plus 4 x's. Well, 2 minus 1 is 1, plus 4 is 5 x's. I have gathered like terms. But there are other questions. What about this one? This and this are not like each other. I cannot gather those together because they are not like each other. But that is like that, and that's like that. So I can gather them. At this point, you have to be much more careful how you do this. I'm going to gather these two. And so just to keep track of it, I'm going to cross them out as I use them up, because that's going to help me. When you're really good at this, you can do this all in your head. But when you're initially practicing, you're going to need to do some writing. So I'm going to use the 2x and adding 3x. Remember that these things belong to the term that's behind them. Okay? In fact, this might be a helpful way to think of things. Is if you think of each one of these terms as a unit, like that. Think in those, you have those pieces. So I'm going to do 2x plus 3x. Well, that's easy. I have 5 x's, and I just used up that, and I just used up that. Notice that I used that plus sign up. Now I have 3 y's and 4 y's. I'm going to add those together. I'm going to end up with 7 y's. I'm going to use up this one to add it. So I've got 7 y's, but I didn't use up this addition symbol. So that addition symbol is sitting right there. And this is my answer, 5x plus 7y. I cannot add these together because this and this are not like each other. But this has been simplified. Another example. And now it's going to get much more challenging. Because you see, I have subtraction. When you have adding, you can do anything you want in any order you want because it's adding. This, however, has subtraction, and I can't change this. In its current form, if I start just moving stuff around, I could run into problems because there is subtraction. If you remember, 5 minus 3 is equal to 2. 3 minus 5 is equal to negative 2. Subtraction changes the question. So, how do I gather like terms? Well, if you think back to some of the stuff we learned earlier, remember this. If we have 2 positives and we add a negative, we end up with positive 1. Remember also, if we have 2 positives and take away a positive, if we have 2 positives and take away a positive, we end up with exactly the same answer. Note that these are exactly the same thing. So what I'm going to do is I'm going to play with this question a little bit. If subtracting is the same as adding a negative, I can turn this into an adding question because of this. Let me demonstrate. What I'm going to do is I'm going to turn everything in this question into an integer. Now, these are adding already, so I have to keep them as adding. Because adding 6, adding positive 6, that's exactly the same thing. This is also the same thing. Subtracting 3 or adding negative 3. I've now turned the question. This is exactly the same question. It is no different. I'm just writing it like it's an integer. But you'll notice now there's adding here, and adding here. And because it's all adding, I can move these terms around in any way I'd like. Let me demonstrate. I'm going to put the x's together and the y's together. So I'm going to have x plus positive 5x. So I've taken that term and just put them together. I take that term and put them together. And it's all adding, remember. Everything's adding. And there you have it. The x's are together and the y's are together. Now I can do 1x plus 5x. I can use that up. That's going to be 6x's. Excellent. And notice that I also used up that addition. Over here, I'm going to do negative 3 plus positive 6. If you're not very good at integers, this is a time when you are allowed to use a calculator. I've just used all that up. Oops. I've just used all that up. That gives me positive 3y. And this has not been used, so that goes in the middle. And there I have my answer. Now, I can actually write this in an easier way if I'd really like to, because you'll notice this is all adding. It's actually 6x plus 3y. Though both of these answers would be acceptable because they are exactly the same. There is no difference between this and this. They're just written in a different style. Now, more examples. Once again, I have subtraction. That makes the question harder. I'm going to have to work on that. Therefore, I'm going to convert the entire question into an adding question by making everything into an integer and adding them. This is exactly the same question, it's just written differently. Now I'm going to gather the terms that are like each other. So they are side by side, so I can work with them a little more easily. I move the y's over here, move the x's over here, so they're near each other. Next step. 2x plus 3x, well, I can do that. That gives me positive 5x's. Negative 3y plus positive 4y's, hey, that's going to leave me with a single positive y. I'm going to use that one up. And this adding sign has not been used up. So there I have that. And again, I could rewrite this one since it's all adding. If I really felt like it, I could write it like this. Both of these are correct. Next question. Again, lots of subtraction, so I'm going to convert it all into integers. I have not changed the question. This is the same question. I just wrote it differently. Now I have to put all the a's together. I have negative a, I got that one, plus positive 5a, so I got that one, plus positive 3a, I got that one, plus positive 3b, I got that one, plus negative 2b. All right, I've gathered the like ones. Okay, negative 1 plus positive 5, okay, I'm at positive 4, plus 3 is positive 7a's. And I just used all of that up. Positive 3 plus negative 2 is going to leave me with positive 1. And I just used all that up, leaving with a plus sign in the middle. Again, I could write this simply like that if I wanted to. Of course, if there was a subtraction symbol in here, that might be a little different. But that's the answer. Next question. This one's a little bit sneaky. if you remember, the lazy mathematician, there's multiplication in here. And if you remember that multiplying, it doesn't matter what order you multiply in. Keep that in mind. So AB plus AB plus BA plus AB. These are not alike, someone is going to say, except that they are. This. Because multiplying is in here, and multiplying, it doesn't matter what order you multiply in, you can actually switch that around. So it's actually AB plus AB plus AB plus AB, because those two are the same. So I have 1AB plus 1AB plus 1AB plus 1AB equals 4 ABs. Next one, a little bit sneakier again. Once again, you have the same thing. This is multiplying. It doesn't matter what order I multiply in. I can actually rewrite that. 2EF plus 3EF plus F. By the way, you'll note in most of our math that it's a convention to put the letters in alphabetical order when you're dealing with something like this. It's actually preferable that way. Now, I'm going to gather the like terms. 2EF plus 3EF. Those are like each other. That one isn't. How many EFs do I have? I have 5 EFs plus F. These are not like each other. But this is the answer. Next question. I have an XY, X, a Y, a B, and a YX. Once again, a little bit sneaky. There's multiplication over here. I can change that. To XY. All right. Those are like each other. But you know what? I've got subtraction in here. All right. I have to turn everything into integers. That's exactly the same question. I'm just adding everything now. Now I'm going to gather the things that are like each other. Well, I got the 6B, so I'm going to put that over here. And I better do the x's. I've got negative 2x. Just use that one up. Y's. Then I have the xy's left. I took care of those. Okay. No other b's, no other x's, no other y's. Those are like each other. So these don't change because I cannot simplify them at all. But this I can. 5 plus negative 7 is negative 2xy's. It may not seem much simpler than that, but it is simpler.